Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm director of the UniZulu Science Centre, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident. Mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations, we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief, experiments are performed, simulations studied, and exam questions are explored, not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer, and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner: learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment, and it's covered using fantastic Pasco software and hardware so that you can actually participate in the experiment. Also, lots of useful simulations, particularly from PHET, the photoelectric effect. You'll talk about projectile motion today, and also momentum. And then talk about applications like what would the International Space Station be without its solar panels to generate electricity. When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it'll show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014 because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck because that only helps with the multiple choice, but I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
You have played for Kaiser Chiefs, for Marisburg United. You are a mechanical engineer. Looking back on your journey, what are you most grateful for?
I'm most grateful for the people that I've encountered.
Brandon, I always say to so many young people that there is a difference between calling and purpose. Right? Calling is what you're called to do on earth. Purpose is malleable, right? It's dynamic. You can change it depending on where you are in the stage of your life. What would you say your calling is and what your purpose is ultimately?
Oh, that's a tough one. My purpose, I believe, was to sort of be a game changer, be a dynamic game changer, as you just mentioned. I always wanted to prove to people that you can have multiple talents, you can have multiple fields that you excel in. And that was just solely based off the fact that I was once told that you won't be able to play football and study engineering, and that sort of set me on a trajectory to say, why can't I? So I truly believe that in that game changing, in that moment, I had a purpose to sort of prove, that this is possible and be a trendsetter basically, because I believe that there are a lot of people that are trying to do the same and can do the same and achieve what they want to achieve in both aspects.
I want you to complete the following sentences for me. Success to me is?
Success to me is being grateful, being happy, enjoying the steps of life that you take. Not only success in the tangible, but success in the mental, in the physical, in the emotional as well.
You are deep, brother. Purpose is?
Purpose is passion. You find your purpose through your passion.
When the world and life gets to you, where do you run to? Or who do you run to?
Well, firstly, I run to my wife.
She's the CEO.
Yeah, you know that. So she's the first point of contact when I need some advice, when I need some guidance. I run to my parents. My older brother, I'm a middle child of three, so my older brother gives me advice, but my younger brother as well too looks to me for advice.
He's also a football player.
Yeah, football player. My older brother's actually a coach at DDC Golden Arrows. So
did my research.
Yeah, I know. So I seek advice from him, but I also give advice because there's someone behind me that's actually trying to do what I did as well too. So.
Okay. I want you to look into that camera and speak to the soul of a high school student or a university student who feels like there's no value for their life. I want you to speak to their soul.
You determine your value. Your worth is determined by you and what you set out to achieve. Block out the noise, focus on yourself, and focus on the people around you that are pushing you to be better and do better, because they believe in you. So why wouldn't you believe in yourself?
Block out the nonsense and focus on what matters.
Yes, definitely.
You matter. A pleasure.
Thanks for having me, sir.
Hello, Itumene, how are you?
I'm good, thanks. And
Great, thank you so much for joining us.
yeah,
Why is the study of science so important?
study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything, just reading and doing like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention and say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right, so I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I will speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now.
Now I'm doing PhD. Looking back, it's like it never happened. So yeah, not giving up. Just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience, perseverance, it becomes very important.
Yeah.
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life, and eventually when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives, just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
Yeah, it was the same for me. Like I said, somewhere, somehow I did get some zeros there.
Yeah.
But then through dedication and, coming from where I come from, and you are at this side, you've made it to university. Somewhere, somehow, winning is the only option. You have to win, like it or not. You going back to where you come from, you're just going back to that life of drugs and whatnot, and that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot. I think you'll get there eventually.
You know what they say, if you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail pre-10 three times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way.
And
I'm
a
a part-time lecturer at the physics department.
I mean,
So, yeah.
listen to that. Listen to that. Thank you so much. Really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashela. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding, so always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry, so I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaha Madiha. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history. Physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, and physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Physical science is very bad, then it means the whole science, engineering, and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat, and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. If they're saying be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying you are all geniuses. You are all going to make it. What I want to tell you is believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult? Yes, work energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here. Here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you're all right. Or, but Ara, which one? Oh, sorry. Who said that? You. Tell me, which Ara? The small R, yes.
You say rice, A plus B is C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T, and in the meantime, this is starting to increase. Hence, I have my plus T. And then at equilibrium, this is the end of your reaction, nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. But hey, I'm not going to complete this one. You can leave it there for now.
What do we have over here?
Okay, so this is one of our smaller telescopes. It's a 6-inch telescope of Jupiter, and you also see the marks on Jupiter's side.
No way, in South Africa.
Yes, sir.
Here, in
Yes,
the motherland. Chai.
We'll ever trust, yeah. No, I don't wanna waste what's left. And on we'll go through the wastelands, through the highways, till my shadow turns to sun rays. And on.
Okay. So the future is too bright, as you can see with my upgraded sunglasses. So I'm standing next to the South African Quantum Technology Initiative stall or exhibition stall here at the National Science Week launch. And this is why, ladies and gentlemen, science rocks. And science is for everyone, just like that handsome fella over there. Hello, dude. Hey. Oh, it's me. All right.
Echoing around these walls, fighting to create a song. I don't wanna miss a beat.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good morning, ladies and gentlemen. Can anybody hear me?
Yes, Dr. Kunan, I can hear you. I guess everybody else can hear you as well.
All right.
But
Well,
let them respond. Let any of the learners respond so that we must be sure they can hear you as well.
okay.
Learners, kindly
Yes, we
respond
can
to
hear
men.
you.
Loud and clear, loud and clear. Can hear?
Right. Thank you very much for joining us. My name is Suela Kunwana. I am with Professor Mulawuzi, the one who just spoke right now in the background. Together, and you guys, we are going to be dealing with chemistry and preparing ourselves for the last or the final kick. You have made it so far from the beginning of not even this year. You've been on this journey from 5 years ago already. And now you are at the end, finishing off your high school and getting ready for next year. That would be your university or wherever you will be going from here on. Now, before we start with the paper itself, I need to highlight certain things that may not even be covered in these slides. I'm still demanding that you go and do your definitions. Your definitions, they worth about 20 marks out of 150 or even more. Remember, you've got 9 questions, and in each 9 questions, you've got 2 marks for each definition. I'm not talking about explanations here, it's just a definition. And again, in the multiple choice, you do come across definitions here and there. These are the things that you need to put aside. You make a list of, you know that these are staying in your head, non-negotiable, you put them down, you know you're sitting with your 20 out of 150 already. And then we will move on to the next phase. Before I can move on to the next part, Prof, do you have an input or anything to say?
Thank you, Dr. Kunana. I would like the learners to take into mind that when we talk of definition, it's not just hearsay. There must be key words which they emphasize. There must be key words because the examiner marks the key words. He doesn't or she doesn't just mark what you are saying. So in each and every definition, there must be key words that should not lack in that particular definition. Thank you.
Thank you, Prof. Another thing that is most important, if you have any questions or you're not clear of anything while I'm talking, feel free to raise a hand or you can type into the chat. There are lots of us here who are monitoring the chat. As soon as something comes up, they will let me know so that I can stop and we address your matter immediately. Remember, we are here for you. You are not just sitting at home like you're in church, listening to the sermon. You will ask questions, you will be asked questions, and you must answer them. And if you ask questions, your questions will be answered back. Okay, these are the house rules. So far, so good for how we're going to run our workshop. Another part, okay, before we move on to the next phase. Prof, can I move on or just
Yes,
general?
move on.
Okay.
Yeah, move on, but let's give them a minute if there's anything they would like to ask or if we're not audible enough. What I want from them is that they should be free, that they should know this is more for their benefit than for us. So they must make the most out of this one. They must really, really participate. Thank you.
Because if you don't say anything, we won't know. And it's not nice for me to talk alone. I like conversations. I don't want to preach. That is my challenge. And remember, you are the one who's writing the exam. So it is up to you to talk and ask. Even if you know something, say, yeah, I know this, but if I put it this way, will this be correct? Or tell us, I don't like how you put it. Let's put it how you like it to be put. It's not a problem. We are here to address such things. We've got it 3 hours. So let us push to make sure that everything is in line. Then we will see what happens. Another thing that I noticed that we learners do in the past, you're going to stop and break the cycle. Multiple choice questions, those are 10 questions. Out of 10 questions, 7 are easy and you can obtain marks from them. The 3, they're not difficult, but they need you to think harder. So I suggest before you even start with your exam, you start with the multiple choice because, I mean, it's easy. Unlike you starting with the long questions, and then you get stuck there, you waste time there. By the time you get to the multiple choice, they tell you it's 5 minutes left. What do? You start picking on letters. And I'm repeating myself, if you're lucky, you will get all 10 correct. If only bad luck, unfortunately, you'll either score a 0 or 1 out of 10. So why do we put ourselves through such heartache when you can work the multiple choice questions? Because they're workable. Right. There's an approach that normally works when dealing with multiple choice. The approach being you start eliminate what is not needed for the question, and then you will end up with the final answer. But let us see what happens. Right. I know in your question papers, you start with organic chemistry and then followed by rates of reactions, chemical equilibrium, acid and bases, and electrochem. We are switching things around this time. We'll start with electrochems. You know why we're doing this? I want us to start with easy marks to collect, and then we will go to the deeper ones later on. I mean, I already gave you 20 marks from the definitions, and then 14 marks from the multiple choice. Now you're sitting with 30, not percentage, 34 out of 150. Now the electrochem should be able to give even more marks. By the time you're done with electrochem, you will be sitting with how many? About 40 marks out of 150. I know you will collect some of the marks from here. And another thing why we're starting with electrochem today is because most of the time, even in your own schools, this is the last chapter. We always overlook it and say like, it's just like 10 marks or 20 marks, which might not even impact. It does have an impact. And by the time you come to this part, because you know you did not thoroughly do it at school, you just leave it unattended. So today we are going to have a look at some of, it's not going to be the entire lesson, unfortunately. It's just us knowing how to answer questions from the electrochem section. And then acid and bases, obviously, this is where more marks are, the 8 marks and the 9 marks and the chemical equilibrium. And then the rest, you'll have those easy things or easy marks to collect. I hope the setup is making more sense and why, and we understand why we are taking this approach for today. First things first, from your grade 9 already, you've seen the periodic table. I told you even the last time, when you start looking at the periodic table, you will highlight your metalloids. Then you know anything above the metalloids are your non-metals, and then everything else here will be your metals. Once you got this sorted out with your highlighter, obviously you will have this when you write your exams, so that things are clearly visible. Remember, chemistry is all about colors. You're going to use this. You're going to need this. I presume by now you know that be it beryllium. Well, I'm not expecting you to know the molar mass of beryllium, but you've got a periodic table. You can get the mass from the periodic table if need be. Next part. I scooped up a multiple choice question, not so many of them, but 2 or 3 of them from last year's paper, this one year. And then most of the questions from the long questions came from the paper that you wrote now in September. I'm sorry about that, your prelim. The question read, it is very important to read the question. Consider the reaction below. I don't know what is this. CH3, CH2, CH, blah, blah, blah. But I see there's a bromine there. This clearly tells me that this is an alkyl halide. To this, I added concentrated sodium hydroxide. Concentrated, it means I am going to strongly remove something because it's concentrated. If it was dilute or a weak base, it meant I was just going to substitute. Already, before you even go to read your questions below, you've got your answer there. Upon removing this bromine, you got your organic compound plus the NABR. How do I know that this bromine was removed? I'm saying it there by NABR. So this bromine, it should have been substituted by the OH, but I'm going further into my product. I see there's water. So it means I've got an OH here plus one of the H's from the initial alkyl halide, which has resulted into the formation of water. Now, once I'm done with this, first and foremost, I'm looking at the organic compound. Before you even go further, you ask yourself, elimination, I've got major product and a minor product. What is this kind? How do you know that? You use Markovnikov and Zaitsev rule. Zaitsev rule, we said last time when we did the prelim, relates to the elimination processes, and the Markovnikov will relate to the addition. What does this mean before we move on further? Zaitsev rule, we said, if you eliminate the HBr here, your double bond will sit on the carbon that has got fewer hydrogens. That is for the Zaitsev rule. And then for the Markovnikov rule, if you are going to add the HBr to the double bonds, it says the bromine will sit on the carbon that has got fewer hydrogens, and the hydrogen will sit on the carbon that's got more hydrogens. Say, for instance, here you had your double bond. Your bromine will sit here, and your hydrogen will sit on this one here. Right. Now that you understand, you have recalled, you know by now that you've got Markovnikov and Zaitsev rule. You move on to your next question, or the next part of the question. Which one of the following correctly gives the type of the reaction and the name of the organic compound? I'm just going to allow you to guess A, B, C, and D, or just give us the answer, not even guess it, because you just worked it out up there. Can we have a response from the audience before we continue working out our multiple choice question? Any input? Can somebody hear me?
Yes, loud and clear. We're waiting for our customers. Customers, there's a question there.
It's too quiet from my side, so you must say something so that I know that I'm still online. Even the the co-facilitators, please keep me online.
Learners, please let's participate. Otherwise, it's just a hearsay. She's putting a question. The hint that I'll give is that we're dealing with organic chemistry here. So what you should check is what happened to the organic moiety. What happened to... Don't worry about sodium bromide and water. Your answer should come from the major product. What happened to that major product? And what do you understand by elimination? And we're not going to judge your answer and say it's stupid. We're going to help you. And like Dr. Kunana said, rightfully so, we can only help where we know you are lacking. If you keep quiet, we may skip something that you do not understand, and this won't be beneficial. We want this to be beneficial to you all. Please participate.
Okay, without any delays, maybe they are still catching up or gathering themselves. Educators, I'm sure some of you are on the platform. Please help our learners so that they can engage even better. Right. From the table, I see they've given us the types of reactions, which is elimination and addition. And already I have eliminated addition up there. I said this is elimination because of the concentrated sodium hydroxide. That is the first bit. And another thing, well, the major and the minor that, yes?
Sorry to intervene. Somebody sent a message. She said B. Somebody sent a message and said B. So that person is participating by putting a letter. Thank you. Thank you.
Right. Now, for the method that we have highlighted that HBr was removed from our initial organic molecule, we can see that compound Q, we're expecting it not to have any alkyl halide or a halogen to it. Here is the guide. You see, I've got only the bromine is there. It's there now. It's no longer there. The next bit, I am looking at my compound Q. It's one of 1 or 2. Remember, I mentioned Zaitsev and Markovnikov rule. Yes, they are testing that in this question also. It's just too many things that are testing within the 2 marks. And then we go for the elimination process. Between addition and elimination, which one are we excluding from the answers that we want? I'm going to exclude that because it's not part of what I wanted. So I'm sitting with elimination. Now, between eliminations here, I've got 1 and 2 built-ins. Remember that who said the double bond will sit on the carbon that has got fewer hydrogens, which will be there. There's my 1, 2, the double bond is sitting there on the second carbon. So whomever said the answer here is B, I will give you a round of an applause. Your answer is definitely correct. So do you see how we go about working out a multiple choice question? And you must not spend more than a minute doing a multiple choice question. They're easy and straight to the point. Work them out and we move on. I wasted more time onto this one so that I can show you how you work things out and how you arrive to your final answers. And we do the same with all the multiple choice questions. You get rid of what you don't want, you stay with what you need, and then you get.
You'll pardon me. I'll now and again disturb you because I'm seeing the question. This learner says, without waste of time, will you be able just to draw the structure, or is your explanation enough?
You want
Maybe
me
she
to draw
just
the
want to
structure?
see. Yeah.
The structure
I'm
of
not sure,
compound
but I think,
Q.
yeah,
Let them
yeah, of the
see.
product.
Yeah, but here's the structure here. It's here. The only thing that is going to be there is that you don't have the bromine and you've got a double bond and 1 hydrogen is not there. So it will definitely be, let me see if I can draw here. C, H, 3, C, double bond, C, 1, 2, 3, 4, 1, 2, 2, 3. Your H will be there and your other H will be there. But they don't ask you to draw this, so do not waste time drawing this compound. You can draw it now while you are practicing and preparing for exams. But in the exams, do not bother to write this because you're going to waste time. Is it fair and fine enough? Are we okay now? Okay, can I move on?
Yes, Doc.
Right. Oh boy, sorry about that. I didn't know this thing would stick on. Where's the eraser? Right. Another question, consider the 4 organic compounds. This one I picked specifically because it's a graph and I need us to look at the graph. The graphs are all over the place and everybody's complaining about the graphs. So like, hey, these things are giving our learners problems. So consider the 4 organic compounds. I've got an alcohol here. It's a carboxylic acid, aldehyde, another aldehyde. Between the two here, this aldehyde is branched, this one is changed. So that means, remember now when you're looking at this, when I'm speaking of the branch and the longer chain, you are referring to the boiling point. Remember, the longer the chain, the higher the boiling point. You keep that in mind, and then you move on to what is being asked of you. The heating curves of the 4 organic compounds were obtained below. This is an increase in temperature and the duration. Which curve represents the heating curve of butanol? You are going to ignore the first two. You're only focusing on the 2-methyl propanol and butanol. Let us see. Well, before you even start ignoring this, which will have the highest boiling point? I think P has got the highest boiling point there, and that should be your carboxylic acid. Why would you say that? Remember again, carboxylic acid, it has got the hydrogen bond and the second, what is that thing again they call it, Prof? The second side or what? Yeah, the hydrogen bond. Prof?
I I'm trying. Okay,
But
there's a
would
question
you?
there from Muliti. She said hydrogen bonding at two sites. From
Aha, that is.
Muliti. Yeah.
Thank you very much. That is what I wanted to hear. So that means propanoic acid or carboxylic acid will have the highest boiling point. It will be followed by the butanol. Okay, butanol, because this is an alcohol and the alcohol also has the hydrogen bond. So that means Q will be your alcohol and your P will be this one. So the two are eliminated already. A and B are out. You are left with C and D. So between C and D, which one? And when you go back up, the both of them are aldehydes. Now between the aldehydes, which one will have the highest boiling point? Remember I said the longer the chain, the higher the boiling point. And butanol has got 4 carbons and propanol's got 3 carbons. This one is the shorter chain and that one will be the longer chain. So between the two here, this one will have the higher boiling point compared to this one here. Therefore, and hence, we conclude that your R will be your butanol and your S will be your propanol. So this is how I'm going to give you these few answers for now, but further on, people are going to have to participate and give us more answers. So that is how I came to the conclusion that curve C is correct. But in curve R, I'm sorry. So do you see how easy and quick it is? It's all about the acquired knowledge, the theory that you know from your entire syllabus. Every time when you look at the question, you recall and you apply. Okay, if we're happy with the slides, can I move on to the next?
Yeah, move. I don't see any question.
Yeah, like I said, I just picked on graphs randomly so that we can attend to them. I like graphs because answers are there. They are very simple and straight to the point. I'm looking at the Maxwell-Boltzmann energy distribution curve for P. This is a carbon dioxide under certain conditions. Curve Q was obtained after a change was made. What comes to your mind when you hear Maxwell-Boltzmann? Temperature mainly, and what else? Catalyst. These are the two that come to your mind first, before you can even consider other conditions. Which one of the following represents the change made to obtain curve Q? Activation energy was lowered. Yes, something changed. That much I can say. And beyond this, I don't know much. What would have changed this? Either the temperature, or the concentration, or the catalyst. Let's see. I've got an increase in temperature, addition of a catalyst, increase in concentration, and an increase in surface area of carbon dioxide. Remember, all of these, they can affect the change or the rate being faster. I got this as my answer. Increase in surface area of carbon dioxide. You know why I chose this? Because I see this carbon dioxide up there. But my question to you is this answer correct or not? If it is not correct, give us the correct answer. We've got 1 minute to solve this.
Let's try, let's put our understanding into play. Let's try. Do you think? Okay. Zintombi says C is correct. So I'll note that she said C is correct. Doctor said D is correct. So we've got a competition between C and D. Let's hear. Is there anyone who supports doctor or has a different view?
And remember, I'm the doctor, so I'm supposed to have correct answers. Think harder before you oppose my answer.
Apply what you know. Apply what we know. C, there's support for C. So C, we've got 2. We've got support for C.
Yeah. Guys, am I losing the battle here? No. Kanye?
Yes, Doc.
Are you on my side or the C side?
Yeah. I'm on the right side.
Which is the right side now? My side or their side?
I'm still thinking about it. Yeah.
I see Prof is not on my side also. I'm not impressed. I thought he was my team, but it's fine. It's okay. I'll survive. Okay,
C
guys?
again. C seem to be increasing. Yeah. Because I'm an outliner, I would say A. Because I'm an outliner, I want us to debate. I'll say A. And then each has to briefly explain why they are choosing what they are choosing, so that we must all be convinced when we live here. Oh, I was on.
Yeah, you
Okay.
got cut off there.
I've got a friend who said A is correct. Zintombi, please give your answer again. I think it left my screen too quick.
Sarah was saying that A is incorrect because he said A is correct.
Okay. So A is incorrect. Say Morph should say B is correct. Morph, I choose for you B. Say B is correct. We want to see who will support you.
Yeah, I would like to hear why the B is not correct if I choose the B than being told that is incorrect. So I need an explanation of why my B is not correct.
We're trying to get. Yes.
That will go back to what Dr. Kunana said in relation to the eliminations. Thank you.
Thank you.
Colleagues, I'm going to call you colleagues, my learners, because from now on, you're no longer learners. You are ready for matric. So after matric, you're no longer a learner, but a colleague. I told you I chose D because of I see there's carbon dioxide here and there's carbon dioxide there. That's why I chose D. I see the link. And somebody chose C. Why did you choose C? Prof?
Yeah, I'm waiting for one who said C so that she or he must substantiate. We're not grilling you, we just want to understand so that we should try and guide you correctly.
Okay, ma'am, and Sir Usi, I've chosen C because Usi is the increase in concentration, and I've compared the two graphs, which is Q and P. And when I'm seeing UQ, I see that there's an increase in the number of particles. So that's why I said there's an increase in the concentration of the carbon dioxide gas.
Wow. Okay. Thank you very much. Spot on and without any waste of time. The correct answer here is C. Now let's go back to why my D is not correct. It says here an increase in surface area of carbon dioxide. Obviously, this one must feel the reaction. Yeah? But looking at the two graphs here, compound P, it only has the original amount of substances according to what the graph is saying here. Now, when you look at compound Q, there's an increased number of particles. Simple and straight to the point. And here it's only talking about the surface area. It's not talking about the additional amount of the particles. And the catalyst only speeds up the reaction. So for the catalyst, we would have expected the same graph sitting on the same spot, but this would have been lower. Like on the same particle here, let me try to draw here and see. I don't like this color, man. It's ugly. Can you change the colors?
Yeah, you can change the colors.
Yeah, but they're taking long. And I can't get them. Oh, yeah, there we are. Let me try that. You see that? That would have shown or happened had you ever, if you had increased the temperature or added the catalyst to P. But now you are seeing Q's gone up. There's something that is completely new. Are we clear, guys? So that is how you eliminate or get rid of what is not needed in your multiple choice questions. Are we happy now? Can we move on to the next part? Yes?
Yes, we can move.
Right, thank you. I promised you to only show you the 3 multiple choice questions. Now we are on the next part. It's still part of the multiple choice. I think this is the last one. A specific indicator is colorless in an acidic solution, and it's pink in an alkaline or a basic solution. The general equation for the indicator is down here. There's your indicator. I'm suspecting this is phenolphthalein, water obviously in solution. And after the arrows, I've got my basic substance, and that is my acid. The indicator is added to a sodium hydroxide solution. They already told me up there. If you add the indicator to this solution, you will see a pink color. Which one of the following combinations are correct regarding the color of HIN and IN minus and the shift in the equilibrium? So they're looking for 2 answers here. The first part, it says which one of the following combinations are correct regarding the color of HIN, and IN minus. Sorry about this typing error. This part, it's my acid, and this is my base. So this I'm expecting to see pink, and here I'm expecting to see, let me use a pencil again, it's much more convenient. I'm expecting to see pink there, and there I'm expecting to see colorless. And then after you see this, then you will be able to answer where the shift will go. It will either go to the right or to the left. I'm looking at the table that is given to us. HI pink. Already I'm eliminating it. HI is supposed to be colorless. IN colorless, no. IN pink, yes. Again, this I'm eliminating, and I am left with B and D to choose from. And these two here, let me do this. I don't want this. So we will decide whether our equilibrium will shift to the left or to the right from here. Okay, let me erase this first, because it's still going to show in the next slide.
Zintombi says D.
Zintombi said D. Very much, you know, while I'm doing the cleaning up here and somebody's doing this, I'm so happy. Right. Before we even start to answer this one, let me take you back with the indicators. If you can, take your phone and snap or screenshot what is happening here on the top. I'm not saying you should go and memorize this, but it will be a bonus for you to understand the table. Like when you add methyl red to an acid, the solution will be red. To the base, the solution will be yellow, and so forth. And these are the saying you should go and memorize this, but it will be a bonus for you to understand the table. Like when you add methyl red to something just happened. My audio was just replayed back to me, hence I was quiet. I'm so sorry about that. I don't know what is happening. Are we fine now? So far, so good?
Yes.
Okay. This
I don't know,
part here,
Sibelo, Doc, I think I saw Sibelo wanted to say something, unless if it was a mistake. Sibelo Vumba, you unmuted briefly. Did you want to say or ask something? Sabelo. Sabelo, the whole train is stopped because we want you to respond. Did you want to say something or it was a mistake? Okay, let's move on, Doc.
Yeah, I thought he was responding to what just happened with my audio. Right. The pH range here, this is what is being asked of you in the long question. They will ask you, why did you pick phenolphthalein, for instance, for that particular acid-base neutralization? You will say that it's compatible with the reaction because of the pH range. And for that matter, say for this is a strong base. Obviously, phenolphthalein will be chosen for sodium hydroxide because it's a strong base. And then for the strong acids, you will choose methyl orange, since it is a strong acid, and likewise. So this is what will help you to answer those long 2-minute or 2 marks questions. I brought this again so that we can come back here. They spoke about sodium hydroxide in the question, and the sodium hydroxide is a strong base. So I'm expecting, let me use a pen again here. I'm expecting the pH of around 8 to 10, which is the strong base. From this pH, we spoke of sodium hydroxide. And we said this is the base. This is supposed to give us pink color. There's our pink, and there's the pink. And the acid, it will be colorless and colorless. So you see you are still within the same correct space, because somebody mentioned the answer here is D. And remember, these ones are eliminated already. So we are left with B and D to decide whether the equilibrium will shift to the left or to the right. Apart from here, I'm going to show you something else that you can also use to support, not even in the multiple choice, but in the long questions as well, to support you to recall the indicator choices. For phenolphthalein, it sometimes will help to recall colors. This is the colorless, and that is pink. That clearly tells me this is basic and that will be acidic. Again, in here, acid, colorless, base, pink. Say, for instance, you are given the methyl orange. Again, for the methyl orange, I'm expecting this will be my acid to be orange there, and then the base will be yellow. The table has got all these color changes and color ranges. Again, for the methyl blue, acid and the base. You will be able to match the colors with the table. And then when you are presented with questions like this, you are able to move forward and answer the question. Now, Prof?
Yes.
Professor, can you please
Yes,
assist further? Yes, can you assist further? Yes, the correct answer should be D here or B. Can you please help our learners with the final answer on to choosing between B and D? Why would you do that? The answer here is now dependent on the shift in equilibrium position. I just need to sort out my network connection here. Just give me 2 minutes.
Let's go back to the original. Can you shift back to the original, because this you were explaining? Let's go to the original answer and the equation.
There you are.
Oh, sorry. Okay. So, learners, let's debate. Why would you choose either right or left between B and D? Remember, let's see if I can. Can you guys see my arrow? Or because I'm not presenting you want? Okay, let's just discuss. Your HIN is the acidic part of the indicator because it has a proton there on the left hand side, and on the right hand side your IN minus means it's a basic part. Do not be confused by the hydronium ion. That's just the product. Now we are saying a specific indicator is colorless in that the indicator is added to a sodium hydroxide solution. Which one of the following combination are correct regarding the color of HIN and IN and the shift in the equilibrium position? So if you've added, let's say the competition is between B and D and the colors are correct. Now, if you add the indicator and it moves from colorless to pink, we say then it's in the basic. And in the basic, if you check there, where is your basic? It's on the right hand side. Are you with me, Lenas? Lenas, are you with me? So the answer is HIN, it's your acid, and IN minus is your base. So you've added the indicator there. It was colorless, it went to pink. So which one, which side do you think is favored between HIN and IN minus? Lenas? Let me see if I can write as well. No, I can't. But let's see. Here, this is colorless. This is pink. Now you add an indicator, it was colorless. So we are saying which side will it shift to? If you are to shift from right to left. Okay, she says right hand side. Yeah. Oh, sorry, I nearly gave the answer. All right. Somebody says right. It will shift to the right. Is there a contrary answer?
No, I agree with them. It will shift to the right because they told us up there In an acidic solution, it was clear, and in a pink in an alkaline solution. And then they gave us this. What is in the product is the IN. There we have it here. So that means this solution is looking pink as we're looking at it right now. And they said here, the indicator added to the solution, they added the sodium hydroxide. Hence your solution is pink. There. So between B and D, it says here, let me take the pen again. I'm sorry to come back like that. I'm so sorry, Prof. I just like somebody.
No, it's fine.
Yeah, somebody gave me an answer and I had to jump on that person. And I like the answer. That's why. Yeah. So it means here our equilibrium will shift to the right. So you see now, again, we had to choose between the two here and how your answer was relying on everything that is on the table. So this one will be excluded and that will be your correct answer. Whoever said D initially, you will focusing on only of this and you forgot about the shifting of the equilibrium. So it is also very important to make sure that we read our questions thoroughly. Okay, ladies and gentlemen, I think we've done enough of the multiple choices. Let's just move on now to the long questions and let's see how far we can master ourselves. So far, so good. We are sitting with how many marks now? 20 for the definitions and the 14 from the multiple choice. Let us go and add more to our basket so that we know that by the time the 3 hours passes from your exam, you are sitting with a heavy basket that is full of marks. Okay. As promised, we said we will look at the electrochemistry. I'm looking at half cell A, which has got the silver there, and half cell B, which is the unknown. I've got silver, unknown. I should have the other known. Something has to give here for me to know what is the unknown, just like in your mathematics. I'm going to use my pen a lot today. A plus B is equals to 4. 4 plus or times T is equals to 4. Let me just write a 5 there. You see, this is known and that's known. That is unknown. Here also, I must have either one of the two knowns, and then this one will be unknown. Then I'll be able to solve my problems. What do I have here? I've got this silver. I have plus, this is cell A, and cell B, I'm just going to call this one cell B. It's equals to, there must be something. This one I know, and this one I don't know. This one must be given. Let me go and read. I'm expecting this to be given. If it's not given, I won't be able to answer this. The following observations were made while the cell was in operation. Cation ions from the salt bridge move into the electrolyte of half cell A. The initial EMF of the cell is 0.03 volts. You see, I've got 2 knowns and 1 unknown. I'll be able to solve my B. Life is easy. Calculate the E cell value of the half cell B. I see life is it's in our favor. They can't just leave us to drown in an ocean. They must give something so that life is easier for us. And there's life easy for us. Let's see. How do we answer 8.1? First and foremost, why did I say I know my silver plus? I went to this table here. I know the table is looking small, but you do have your own papers in front of you. so that you are able to see how the tables, there's my silver, and there's the EMF for the silver, and I've got an overall for the entire cell. There's the entire cell is given to me. The silver one I got from the table. This for cell B, I don't know. And that's how I get my answer. I'm going back to the table. The first thing you do when you look at this table, because this question paper, it was so nice. I think the people who wrote this paper, which were you guys, this September, you had it easy. Sometimes the questions can be more intense and deeper. First thing you do when you look at this table, sometimes it will be table 4A or 4B. Either way, they work the same. 4A, it says here, increase in strength of oxidizing agent. Oxidizing agent, this is reduction. So that means here I'll have my oxidation, and there I'll have my reduction. Likewise, on this side, I'll have my oxidation, and there will be my reduction. Once you write this, and where's my hydrogen? This thing is too small. I'm just going to cross a line over the hydrogen there. I'm not saying that everything above the hydrogen from this side is reduction, and then everything below the oxygen is oxygen, it's oxidation. But we are saying sodium, for instance, down here, it's oxidation, it undergoes oxidation, and the copper here will undergo reduction. Once you know this, you'll be able to answer some of the questions which are not or may not be addressed in this question paper. Moving on to 8.2, write down the half cell for the reaction for cell B. You've got your EMF, which is 0.77. I need to go back to the previous equation. 8.1. In 8.1, remember the signs here. It is advisable for you to write the first equation as it is with the signs there. Should it happen that this or that, or even that results with a minus sign on it, include the minus sign. Because this is where we mainly make mistakes. Say, for instance, E cell is equals to E redox minus E oxidation. Let's say you want your E cell, and this one is 0.08 minus. Say your oxidation there is minus 0.2. I'm just making up these numbers here. It is important to keep them inside your bracket so that by the time you get here, this will give you the correct answer. If you don't put this in here, you assume that sorry about it, 0.2. You assume that this minus belongs to what is in here. Already you're out. So these are the things that we need to guard against, and we must keep in what we are doing onto the paper. You relax yourself, you know the answers, put them down. Don't just keep them to yourself and you assume that ma'am knows that I know. Of course, I know that you know in my school, but whomever is marking your paper, they won't know that you know this. So it is highly important for you to, you can take the longer route. It will put you on the safer side, unlike being quick and then end up making mistakes that will make you lose marks.
Doc,
Doctor,
okay,
oh,
yeah. Go
you
on,
can
man. Go.
Oh, there's a question by Zintombi. She is asking, how did you come about knowing that AG, which is silver, underwent reduction given the E cell?
There's my silver. And remember, I said here, according to the table that I'm looking at here, this is my reduction, and that's my oxidation. I had to do the calculations first. I've got 0.3 or 8, the general EMF. What was the answer that is given in the question? Come on, guys. Hello?
0.3.
It was 0.3, right? That is all I had before doing anything else, and that is my X. So I took this one to the other side. That gave me 0.3 minus 0.8. I had a negative number there, which was 0.5. Why am I getting 0.5 now? It's a plus. It's, yeah, that's 0.8. 0.3 8, it means unknown. 3 minus 8, it's minus 0.5, is equals to minus x. Then the x is equals to 0.5. I've got this EMF value for the other one, which is the supposed to be oxidation or whatsoever, or they are even swapped around. But I've got this value and that one there. At this stage, I don't know whether this is oxidation or reduction. I am coming back here to see what is 0.5. There it's my 0.5. Let's say, for instance, according to what I did the calculations here for, I've got my 0.5 for the 5.2. Let me take this one for now. 0.52, which is my copper. The copper is sitting here at the bottom, and where's my silver? The silver is up there. So it means here my silver here is reduction, and the copper will be oxidation. That is how I could spot that silver is reduction and the other part will be oxidation. You can even write this the other way around and say 0.3 is equals to x minus 0.8. You can still do this because you don't know here. And then same wise, this one coming on this side, 0.3 plus 0.8. Whatever answer that you will get, it will give you the x. And from there, you come back here, you check your EMF values. You will see which one is sitting on top of the other, according to what we have deduced from this side.
Doc, another hint, which will be much simpler, would for them
share that with us.
To look at the half cell that is given. Sorry. So the half cell that is given already in the paper, they wouldn't have two half cells that are the same, which will be much quicker. Yes, thank you. Was I too fast? If they go back and check what they've been given in the paper as a half cell, so it would give them an indication that the second one won't be in the same range as that one. which is much quicker.
Yeah, I wanted this. Yes, I think so. Oh, okay, 0.03. Wabona. That's why my answers were not coming right. I'm feeling very stressed up now. Right. But anyway, did we see what we tried to show you guys?
Yes, ma'am, understood. Thank you.
Right. Right. Write down the half cell of B. It's there. Must you think hard about this or trying to figure out? They said it's 0.77. Did you not see that? There it is, 0.77. You are still looking at your table. There's your 0.77. It looks like iron, but I'll give you the answer in the next slide because these things are too small, I know, but I presume you do have your tables in front of you. You're able to follow what we are doing. I'm so sorry to keep on going back and forth, but we are just trying to emphasize something here. There it is. You take it directly from the table. It's nothing to think or even to negotiate or try to be smart or try to write this in Chinese. Whether you write it in Chinese, English, or mathematical expression or whatsoever, or in Soto or Zulu or Afrikaans, the answer will still be the same. You took it directly from the table. What is the cell notation of the entire thing? You know that this is redox and this is oxidation. What stays? This is the salt bridge. What stays on your left-hand side and what stays on your right-hand side? Is it oxidation here or reduction there? Come on, guys. This is the part that confuses me. I'm not sure what goes here.
Oxidation on your left-hand side.
Oxidation on the left-hand side and the reduction on the right-hand side. Ne? Is there any mention of a catalyst here? Did they mention a catalyst?
No, ma'am.
If it's not mentioned, you don't bother with it. But if it is mentioned, you will definitely have to add it in your cell notation. See, there's a catalyst there, and there's the silver. Even if you don't add it here, it's fine. Because it's not mentioned here. But once it is mentioned in the question, it must reflect here. Okay, guys? You see they've put the 1 molar here and the 1 molar. These are standard concentrations for a cell, be it electrolytic cell or voltaic cell. Unless if they have specifically told you to change the concentrations on the whatever the question that is given to you, then you can change. But otherwise, you keep it as 1. Remember the STP. Remember STP, standard temperature and pressure. You have your volume to be the same, the temperature, the pressure. Same applies here. The concentration will be 1 mole per decimeter cubed. Are we clear, guys? Are we loud and clear? Sometimes you might even be given the cell notation and be asked to interpret what is given here. You go back to the statement that is given. You tell us this is the anode, or this is not the anode, don't say that. This is oxidation, and that will be your reduction. Why do I refrain from you not saying anode and cathode? It will depend on the type of the cell that you're looking at. Sometimes you're given an electrolytic cell, sometimes it's a voltaic cell. And you know these two are opposite of the other. And you must also tell us what is this? This is the salt bridge. What are the the purpose or the uses of the cell bridge or the salt bridge, I'm sorry, in the electrolytic cell. Why I'm highlighting all of this, they are not assessed or examined on this question paper, but I need you to go and recall everything. So whatever that will come to my mind, I will put it down here so that you are preparing yourself even better. Can we move on to the next part? Prof, is there anything else that we need to add?
No, it's just the hint that I gave. If they check the half cell A up there, they can see the oxidation number moves from positive to negative, even if it's 0, but it means this one has been reduced. And if they now go to what we were trying to do, calculate, and I said this half cell A should give them a hint what's happening with the unknown. That's the answer the lady was seeking for, which I said would be a fast, quick way of knowing, because they cannot give them reduction. That's all.
Prof, can you repeat yourself again? You were going too fast there.
Okay.
You
What I
spoke
was
about
saying.
no. You spoke about the negative and the positive.
Okay.
EMFs. Yeah.
AG plus. Yes,
Can I write
AG
that? Hold
plus.
on. Take your time. Let me write. AG
Okay.
plus.
AG plus is moving to AG0. Which means it's a reduction.
Straight to the
Which
point,
means
without
that
even going further.
exactly. Thank you.
And if this one is reduction, obviously the other one automatically becomes oxidation.
Oxidation,
So do
yeah,
you
which
see,
will
guys,
be a quicker way. Yeah,
do you
thank
see,
you.
guys, without doing the calculations, do you see, guys, that your answers are here in your statements before you even attempt to answer questions that are asked? 8.2.3, it says, give or write down the 2 standard conditions for this cell. I gave you the standards in the previous slide. The concentration, what is the other one? I'll give you one here, which is the concentration. What's the other one? Come on, guys. You saw the cell notation. What is in the cell notation? What is in the cell notation? Apart from the what is this now? From the silver and the iron. You saw 2 plus there and the silver. And you said this is oxidation, that's reduction, but there's something else that is on the cell notation. Yes?
Ntombi says the catalyst.
Catalyst. Thank you. And what is that catalyst again? Platinum. Can I give you a tip? Whenever they ask for a catalyst, even when you're dealing with organic chemistry, don't try to go to America and Google in your brain and do funny things. Use platinum. You'll never go wrong. Are we clear, guys? Stick to platinum. Your life will be safe. And then another thing that they like to ask here, they might ask, while we're still on the conditions here, again, we said the standard condition, it's 1 mole per decimeter cubed. They might ask you, what happens if you increase the concentration of one of the electrolytes? What will happen to the EMF of the cell? I've seen that question previously being asked, but here it's not asked.
Doc, there's a question. They're asking, what about temperature?
Temperature is also part of, that could also be. depending on the cell that you have. Remember, we've got the electrolyte and we have the voltaic cell. One of them does not require electricity here or heat. Look here on 8.2.4. You see that? This will tell you if the temperature is needed here or not. I was going to come to that one. We will answer that question now. Let us start with the concentration first, and then we will come to the temperature story here. Now, if the concentration is increased, let's say for instance, let me go back to the okay, let me write it here. I think it will be better instead of going back and forth. Say you have your I'm not going to balance this thing. Yeah, 3 plus. So that will be your general. It's not balanced yet, but we keep it as is. And then we happen to change the concentrations of any of these here. We increase the concentration. You treat this as like you are doing the Le-Chatelier's principle. You increase the concentration, what will happen to the equilibrium? Will it shift to the right or to the left, depending on what is increased from 1, 2, and 3. Are we clear, guys? Here is not asked. What if they say the concentration of iron 2 plus was increased? Obviously, your equilibrium here will shift to the right. So if it shifts to the right, it means something here will happen with your EMF or the E cell. And what happens to the EMF? It will either increase or decrease depending on the setup that you have there. I'm sure when you did your revisions and so forth, you have dealt or seen such a question before. Now, the temperature is also one of the conditions depending on the type of the cell that you have, whether it's an electrolyte or the voltaic. The energy conversion that takes place when the cell is in operation. First, you know the mistake that we did here? We did not ask what type of a cell are we looking at here? Is it an electrolytic cell or is it a voltaic cell? What kind of a cell are we having here? Yes, guys? Can anybody answer that?
Let them look at the following observations were made while the cell was in operation. That will also give them a hint.
Oh, there are two answers on the chat box.
Yes.
Zintombi says galvanic cell, and Mulete, I'm sorry if I'm butchering it, says volcanic cell.
Yeah, it's the same thing. Galvanic cell or, look at me now, what am I doing? Galvanic cell or voltaic cell is one and the same thing, which is correct. Now you can be able to tell us if the temperature could be one of the standard conditions here or not. Are we clear, guys?
Should they identify it voltaic or galvanic to help the other learners?
They said it's galvanic, but when I'm reading the question there, the question is telling me a different story. The statement. Are we all seeing the statement there? The following observations were made while the cell was in operation. Cations from the salt bridge move into the electrolytic or electrolyte. Yeah, I'm sorry. I thought I was reading something wrong here. Whomever said galvanic or voltaic, it's 100% correct. Now, what is expected of the energy conversions here? Remember, the conversions is from, I'm just going to write this down. I don't know if people understand what is the E and what is the C, but I'm just putting it down there out of spite. What do we understand the E standing for and the C according to the energy conversions here?
There are also answers on the chat box. They're saying chemical to electrical.
This will be electrically, and that one will be chemical. So what is the energy conversion involved here? Chemical to electrical. So one of the standard conditions here, will that involve the temperature as well? You know what I'm enjoying about this topic or this question that we're looking at here is because people are recalling and you know your answers and you've got them right. So do you see, because this is fresh in your mind, once you see your question paper, you will jump directly into question 8 and 9 and answer these questions because you know them. The 13 marks is sitting there on top of the 20 plus 14 plus 13. Do you see how we add up or compile our marks? Instead of you sitting there in that organic chemistry trying to draw the molecule that is difficult for you, time is running out on you. By the time you get here, you are out of time and you don't even know what to do. Are we clear, guys? But I'm still waiting for an answer here. Is the temperature part of the condition or not? Kani, is there anything that is in the chat?
They say it's not. They say the temperature is not part of the standard conditions.
So when you change from chemical to electrical, you don't need a temperature there. Okay, guys, without any waste of time, because we've got lots to cover, can we just move on? But before we move on, yes, to change from chemical to electrical, I don't need a temperature, but the temperature is needed when you convert from electrical to chemical. You are using energy there. H.4, the concentration of silver plus is increased in a half cell. I've already told you what is happening here. I wrote the cells there, and I said to you, what happens if you increase the what you call it, the concentration? They might ask you the direction of the equilibrium, whether will it shift to the left or to the right, or they might even ask you what will be the reading of the voltmeter after. What effect will the increase in the concentration of Ag plus in the half cell A have on the initial? There it's asked on the initial EMF of the cell. Choose from increase, decrease, or remain the same. They've increased the concentration of this. What will happen here? Obviously, your equilibrium will shift to the right. You will have more of the Ag. Now, the question asks, what happens now to the EMF? Will it increase or decrease?
They're saying increase. I'm kidding. Increase.
Increase. You see, learners like this topic, but it is so deprived of them because of time. And it hurts me. So why are we not focusing on things that will give us marks so we can get our distinctions and pass? Hey. Ne? Prof?
Yes.
Prof? Yeah, without any
Yeah.
waste of time, can you please elaborate why would this increase so that we can move on to the next sections? We've got lots to do.
Okay. Remember that the energy conversion is simply the flow of electrons in that way. So if you increase the concentration, it means you're going to release more electrons. So it will initially increase, spike up, and then later on it will stabilize, but there'll be an increase. Either when you increase A or B, there should be an increase in the voltage.
Thank you very much, Prof. I hope that was captured by everyone. Remember, if you did not capture anything, you still can go back and listen to the YouTube because this is live and it will be recorded also. This is another part. The next question. Remember, electrochem, it's 2 questions. Just like how you deal with organic chemistry, that's for 3 questions. This one will have 2 questions. It says here, define an electrolyte. Now I'm not going to bother with this. I told you the 2 marks I want and you give it to me, whether you like it or not. Name a substance or a suitable solution, I'm sorry about that, that can be used as an electrolyte in this. I gave you an answer because I was bored. But most of the time, the sulfates, the nitrate, and the chlorides will be your electrolytes in such solutions like silver nitrate, not silver chloride, I'm sorry, silver sulfate, copper sulfate, and so as long as these salts are soluble in water. Silver chloride is not soluble in water, so it cannot be an electrolyte. And this knowledge you know already from grade 10 when you did the solubility rules and when you did your precipitation and so forth. Write down the equation for the half cell reaction taking place in the anode. Where are the questions, man? I'm so sorry about this, but where's the question? Oh, is it sitting up there? There's something black sitting there that is disturbing me. I can't see the question. Sorry about that. I'm so sorry about this black thing here. It was sitting on top of the question. I could not see what is happening there. Impure copper is refined using an electrolytic process as shown in the table below. I've got only 1 cell here. I don't have the 2 of them with the salt rich on top. So this tells me this is an electrolytic cell. And you know, sometimes, I mean, it's common sense. The previous question they asked about the galvanic cell, why will they repeat it here? Obviously, the next one will be the electrolytic cell. Right? We can just check the system and see if we cannot go up and above ourselves. Okay, guys?
Doc?
Yes?
You gave them an answer about a suitable solution. Now, an uncle's tip why they should choose the answers that you gave.
Let me put the answer.
Yes.
Yes.
It's because here there's a hint. It says impure copper is refined. So if it's impure copper, it's going to be refined to pure copper. So hence the choice of copper 2 sulfate, copper 2 chloride, or any other copper 2 solution. I hope they understood that. Yes, thank you.
And again, this part here, the sulfate and the chloride, because you can't just say copper 2 plus. They want you to say suitable. If you write copper 2 plus, you will lose marks.
Yes, thank you.
And it's also highlighted to look at organic chemistry that you no longer use H plus, but you will write HCl or sulfuric acid or phosphoric acid. Ne? 9.3, write down the equation for the half cell taking place in the anode. By now, looking at this, you must have read the section about the electroplating and what else? The refinery of copper or something of that sort. By the time you come to this question, you've got all this acquired knowledge that you brought forward so that it can assist you to answer your questions. All these questions are sitting in that section. What is important is for you to know where the answers are sitting. If the answers are not anywhere in your files, in your brain, and they're sitting somewhere in your textbook, it's not going to be easy for you to answer them because you never took them from the textbook and into your head. Okay. Prof, I need to also highlight something here, and this is to our learners. This is one portion where they might ask, they are talking about the copper here, the impure copper, and something has to be removed from a copper into something. This is now the electroplating. And then there's a question that they like to ask about the increase in mass and whether that will be reduction or oxidation. Can you give us a picture of that? Because I don't think that question is addressed here in this question paper. But let me check something before you can address that so that we can put something in front of our learners. This is 9.4 here. A precious metal such as silver, which is usually part of the impure anode, sinks at the bottom of the cell. Explain this observation referring to the relative strength of the reducing agent. Can you give us the scenarios, like different parts or portions or spaces that can be asked within this question here? Because yes, we can see that the silver is going to be platted with the copper, or is it the other way around? The copper can be platted with the silver, but one of the two will have the mass reduced, and then the other one will gain mass. Before we answer 9.4, can you please assist us with that question?
What they need to understand, which I think by now they know, is the difference between electrolytic and galvanic or voltaic cell. And they can see up there the two lines that are different. This is the external source. This is the external energy source. In chemistry, we call it a battery. Physics, they'll call it a cell. Because they say a battery is made out of different cells, but that's not important. Let's explain the chemistry way. Now, it means now, remember, with the galvanic cell, the electrodes will have their charges. For example, in a galvanic cell, the cathode will be positively charged and the anode negatively charged. So what happens is that now the roles here change depending on which part of the cell is your electrode connected to. If your electrode is connected to the positive terminal of the cell, then it means it is now positive, and electrons will move from the negative to the positive. So remember you have the anode and the cathode. And at the cathode, reduction occurs. When it occurs, it forms a solid. So it will form a solid at the cathode, which in this case is going to be negative because it's attached to the negative terminal of the cell. But still, electrons will move from the anode to the cathode because the cell there in the middle will serve as a pump. It pulls electrons from the anode and pushes them into the cathode as much as the cathode is negative. So what will happen is that reduction will occur at the cathode. So the mass of your cathode will increase. This will be the pure metal that is surrounding or getting deposited on the cathode. I will repeat. The pure mass will be deposited around the cathode because at the cathode, cutting, it's where reduction occurs. And reduction is constituted by the formation of a metal. Is that clear? Do you think that is enough for them to understand?
Loud and clear, Prof. Loud and
Thank you.
clear. From my side.
But let them ask something if they do not understand. Let them ask before we proceed.
Before we move on.
Yes. So the operation of the cell does not change. It's only the charges. So at the cathode, a reduction still occurs. At the anode, oxidation still occurs. Oxidation is the release away of the electrons. But then because of that cell, external energy source, the electrons are then forced. It's like you're pushing something against the slope. So it means you must apply force. So electrons on their own will not move from the anode to the cathode in an electrolytic cell. So electrolytic cell is changing, converting electrical energy into a chemical energy. That chemical change is the one that forms a pure metal. Whether it's electrode depositing or refining the salt is the same principle. Thank you.
Thank you, Prof. Are we fine, colleagues? And ready to move on? Oh, sorry. I'm so sorry. I do apologize for this. We did not come back to the question and I already gave out the solution. The question asks says that a precious metal, such as silver, which is usually part of the impure anode, sinks at the bottom of the cell. Explain this observation referring to the relative strengths of the reducing agent. So for you to answer this question, you need to have that table again in front of you. If you're stuck, you don't know what to do. But you will see there on the table, you'll see where silver is sitting and where copper is sitting. Then you'll be able to see which one is able to reduce the other and which one is able to oxidize the other. Right? And then you'll be able to come and answer this question here. Are we clear, guys? And most of the time, this question, they will give you the original question with the silver and the copper. And then they say to you, what if the copper was replaced by zinc? Will this process still proceed, the process? You go back to the table. The table will tell you that if this one is sitting underneath that one, it means it won't be able to reduce it or oxidize it, or if it is on top of, depending on the table that you're looking at in front of you. We are just giving you general tips here. I know you have the memo. We can go to the memo and answer these questions, but we are emphasizing and highlighting how to look and how to further or more understand the concept here and without any delays, because remember, time is not on your side when you write exams. After 10 minutes, 1.6 grams of copper is deposited on the electrode. Calculate the number of electrons that flows through the circuit while the mass of copper was deposited. This question 9.5, Prof has explained it to you thoroughly without even us looking into the question itself. But now that we see this question, we have a clear and full understanding of what is happening here with the electrons, what is happening with the status of the anode and the cathode, the flow of electrons, what will be the external force, and so forth. Let's say, for instance, if copper 2+ is used in this reaction, I will first calculate the number of moles of the copper, not copper 2 plus the copper itself. This will be the number of moles. And then after this, you can link your copper 2 plus, remember the equation there, 2 electrons, electrons, giving us copper. 1 mole of copper and 1 mole of copper. So they react on a 1:1 mole ratio. Hence, you know that number of moles of copper 2 plus will be equal to the number of moles of copper. You remember the periodic table does not provide you copper 2 plus, it only gives you copper and its molar mass. Some of the questions are just sitting there too, they're noting, they're trying to make us dizzy, but we know our story, so we can't be confused with unnecessary things. Now, let me move on to the next part. So we are clear with the link and the communication or the relationship between copper and copper 2 plus. Since 1 mole or 1 copper atom gives off 2 electrons deposited on the electrons, I am not going to dwell too much on the electrons and so forth. Prof has explained to you further and thoroughly about the process that is happening here. 1 copper gave off 2 electrons. 1 mole of copper is 0.02519. But there's 2 of them. So each copper will give off 2 electrons. So how many electrons, or the moles that will be linked to the 2 electrons from each copper? We will multiply that by 2, obviously, to get the answer that we're looking at here. Okay, the Avogadro's number. In the past 5 years of the past exam papers, I have not seen any question that relates to Avogadro's number until now. So guys, be ready. Avogadro's number might be asked again in the finals. They might ask you to do something that is different. They might ask you to calculate the number of particles or the number of atoms or the number of molecules, depending on what they like. But remember that starts with the number of moles, and then from the number of moles, it will then lead you to the Avogadro's number to get whatever they want you to answer. Right? Before we move on, do we have questions? Are there any questions before we move on here? Yes? Are we moving on?
Yes,
Hello?
but before we move on, kindly repeat to them the stoichiometric ratio of copper and 2 electrons, so that they must understand the stoichiometric relationship between copper and 2 electrons, so that they must understand why now you are multiplying by 2. My laptop is misbehaving now. It's saying
Don't
I have
touch it.
virus.
Leave it alone.
Yeah, I've left it alone. Yeah, what I want you to do is, thank you. Thank you. That's what, because I know normally they do not understand this part.
And this was asked in the previous, I think 9.3 or 9.2, they did ask us to write this half cell. There was a reason for that.
Yeah, boy.
First and foremost, after 10 minutes, 1.6 grams of copper, of pure copper, is deposited on the electrode. Calculate the number of electrons that flowed through the circuit while the mass of copper was deposited. Once we're talking of the deposition and so forth, we are referring to this. The activity of the solution. You can't deposit a solid metal. It has to be in the form of a solution or so forth, so that the electrons can start to move. And I saw somewhere they spoke of electrons. Once I see electrons, I am referring to this. Right? Hence, this takes us to this equation up there. So we move from copper to copper 2 plus and the 2 electrons. Or sometimes this can be written vice versa, depending on whether your copper is reduction or oxidation. Let's say, for instance, here your copper is oxidation, as it is written here. The relationship here is 1 mole of copper is equivalent to, sorry, let me write this way. It's equivalent to 1 mole of copper 2 plus, of copper 2 plus. So whatever number of moles that you have for this copper will be the same as the number of moles of copper 2 plus. And remember, this is not in the periodic table. This will be in the periodic table. Once you get this, it will link you to the copper 2 plus. Now, I am now going to look at the right-hand side of my equation. I've got copper 2 plus there and 2 electrons. Copper here, it donated 2 electrons, or it lost 2 electrons, according to this equation that we're looking at here. The loss of 2 electrons, it says here, 1 copper has got that, and the second, and okay, I'm sorry, and another electron, sorry, also came from the copper. So it means, I need space here. Sorry. So I'm saying here, this copper, it lost 2 electrons. And the question asked here, calculate the number of electrons that are present in here. To calculate only 1 electron here, you are incompleting your calculation. You need to tell us that, but now here, this is where the stoichiometry is coming in. Here, it says 1 copper 2 plus gave us 2 electrons. The stoichiometry here is 1:2 mole ratio. 1 copper gave us 2 electrons. Is that clear enough? Is this clear enough to everyone?
Yes, but I want you to, so that they must understand, start with this one, the one that you wrote on the top left corner, the copper 2 plus 2 electrons to form 1 copper 0. The one on the left-hand side where you've written copper 2 plus 2E. Do you see that one? On the left-hand side. Yes, and then indicate as copper 0. As copper 0, that one. Yes, then they'll understand much better. As copper 0. Good. Now, what Doc is saying is that to form 1 copper mole, 1 mole of copper, you need 2 electrons. That's all we are saying. So, which is very, very important that remember that. Hence, she had to multiply the number of moles there by 2, because 1 copper requires 2 electrons to form 1 copper metal, which is the metal that is going to be deposited. I think this will now explain everything, because we're talking about copper deposition. So 1 copper 2 plus mole needs 2 electrons to form 1 copper 0, which is copper 0 is then the metal that is deposited. And I think that now will clarify everything.
There's the mathematical expression of what you are saying, Prof. 1 copper,
yes,
this is the stoichiometric
exactly.
part of it, is what you wanted. 1 copper, 2 electrons. Gave 1 copper gave us 2 electrons. But we've got the number of moles of copper to be 0.02519. We don't know the number of moles for each electron, which is the X. If we cross multiply, that times 2 will give us the X, which will be the 0.159. Okay, and this type of questions, they appear in the entire paper. You find them for rate of reaction, chemical equilibrium, acid and bases, and so forth. Any questions before we leave the electrochem and move on to acid and bases?
To continue, we made justice to this part. Thank you.
Can't I make this thing smaller, man? This black thing here. The pH of a solution X is measured before and after adding 10 drops of concentrated sodium hydroxide solution. So, okay. So this is sodium hydroxide plus the acid. We don't know what acid is used here. What is meant by the concentrated sodium hydroxide? Remember, guys, I said one of the 1-2 marks, and from the definitions, you have to know what is a concentrated. They're not asking if this is a strong base or weak base. They said concentrated. Be careful of that. And from grade 10 already, we dealt with solutions. We know about a dilute solution and a concentrated solution. I'm moving on to 7.1b. What happens to the concentration of the hydronium ion in this solution? Remember hydronium ion and the hydroxy ions. We've got H3. My pen is on strike. I think the ink is getting finished. We've got H3O plus whenever we're dealing with acid and bases, and the OH minus. That will be our hydroxyl group, and that will be the hydronium ion. You must know this before we move on further. Write down only increase, decrease, or remain the same. Explain your answer. What happens to the concentration of this in solution X? In this solution, now remember initially you had your beaker. In the beaker, you had X. And your X, they said, is this one new. So that means this is an acidic solution. Now to this acidic solution, we've added sodium hydroxide. So that is X plus the base. Obviously, we will have neutral, or we will have base, or we will have acid. These are the 3 scenarios that you can get. Initially, you have this. As you add the base to this, you will reach the neutral part where your titration stops. If you continue adding the base or the sodium hydroxide into this, your solution will automatically become basic. What happens to the concentration of the hydronium ion or this acid if you add the base to this?
Doc, let me give them a hint. Guys, the hydronium ion concentration in solution of the or in the beaker is the same, but then they are adding sodium hydroxide, which in quote is that they are adding the hydroxyl. Now the hydroxyl reacts with the hydronium ion of X. So do you expect the hydronium ion concentration to remain the same or to be reduced or go up as you are adding the hydroxyl? That's all she's saying. So this should give you a hint. The hydronium ion concentration in the beaker remains the same. You're not doing anything, but you are adding the I did not want to use this term, but I'm forced by you now to use it. So the hydroxyl term eats away the hydronium. The hydroxyl eats away the hydronium because it reacts with it, but don't write it. It's just for you to understand. So the question is, as you add your hydroxyl, what happens to the hydronium ion there? Are they increasing, decreasing, or remaining the same? Thank you.
Can you see the graph I'm drawing there? Initially, your pH is low because of the acid. Okay, let me change it. Right? Initially, you have your acids, the pH is low. The minute you start adding the base or the sodium hydroxide, what happens to your pH? It slowly starts to increase. You see that? Up until you reach this part here. This is your endpoint. That means your reaction stops here. If you continue adding the base onto this, your graph will keep on increasing up until it reaches to the point here where nothing happens anymore. So that means here you've got your basic solution and here you've got your acidic solution. So this should be able to help you answer this question here. So if I add the base to this, what will happen to the concentration of the hydronium ion? Will it increase or decrease now? Come on, guys.
They're saying decrease.
Decrease, correct. The graph is telling you. From here, you are no longer looking at the acid. You are focusing on the base. Likewise, when you are dealing with the, let's say in the beaker here, you had a base. Your graph will start up there, and then it will go down like this. The more you add an acid, the pH will drop. So that means your hydronium ions in here, they will increase because you've got more of the acidic solution, and here you've got more of the basic solution. Bearing in mind that this is still your endpoint. So the answer here will be decrease. Why would you say that? Why would your answer say decrease? The answer Prof explained to us while he was explaining or giving us the hint on what needs to be done when we answer such questions. I'm confident with these questions here because I know you guys can answer them, but just don't underestimate yourself or tell yourself that you know and then you don't put effort on these things. You need to, you know what you know, you must put down an answer. Don't just say, I know, and then you leave it from there. Yeah. That's our answer. It's the same. It says it decreases. Why does it do that? Since the hydroxide ions increase, the hydronium oxide will decrease. And yes, your KW will be, it will depend on what you want to do. If you keep on adding the hydronium oxide, this will decrease or change. Okay, guys? These are the small, easy questions that I know we will gather and collect marks from. There's these ones that I need you guys to look into. I know when you come there, you start getting a headache, and there's no need for that to happen. It's still the same situation. They say here, calculate the concentration of the OH minus ions in the final solution. I'm going to draw the graph again to show you what are you looking at now at this stage. There's the graph. you are now looking at something like this. Calculate the concentration of that in the final solution. This was your pH of 7. Remember the neutral part. But then you added more of the base. You are now sitting within this space here. You've got two options here. pH. Ne? You can either do this directly, depending on what you have, or you can use this depending on what is given to you. And in this case, they only gave us, we have the KW and you've got the pH. Remember, guys, this, whatever is calculated here, you can do it this way. Once you calculate this, the H3O plus, you will get the pH. Or if you calculate the OH minus, you still need to come back here to get your exact pH. Remember, your answer, if your pH is below 7, it means you need to come back here to get your pH that is supposed to be greater than 7. Because this is a basic solution, your pH is expected to be above 7. But when you calculated this, they gave you the pH of 12 here in the question. But here, you calculated your pH to be 2. You see that? Once you get this, you need to go back to this and make sure that your pH sits within whatever that you are asked for. If you want the base, it will be above 7. If you're looking for the acid, it has to be below 7. The calculation should not give you a stroke. Say you calculated and you go to 2 here and you're like, oh my goodness, what is going on here? You are on the right track. Just remember what is asked of you. Do I want the pH of the base or the pH of the acid? If it is the acid, you are fine here, you can leave your answer as is. But if it was the base that they want, then you come back to this formula here. You get your 2 and your 14, that will give you the 12 for your pOH. Are we clear, guys? I just wanted to highlight the tips here. I'm not focusing on the question that is asked here at the moment. I'm just giving you different scenarios that might arise while you've been asked to answer such questions or that belong to acids and bases. Remember, we are not here to be narrow-minded or be stereotyped. We need to broaden our horizons and be prepared for anything that might come our way. We will know how to tackle or attend to. Now, coming to the question here, calculate the concentration of the OH minus ions in the final solution. They gave us the pH here of the solution, which is 12. There's our pH, and there's the formula here. And this part, this is where you apply your logs from your mathematics. I'm going to advise this because that's when we make mistakes most of the time. pH, the formula as is, they give you 12, it's equals to minus the log of H plus. Get rid of this minus. Divide both sides by minus 2, then you have your minus 12, it's equals to the log of H plus. Then you can do your anti-log. If this is your base will sit here and your initial base will become the exponent. Then you have your 10 to the minus 12 will be your H plus. This you can punch in directly from your calculator. Remember, if you don't forget to transpose the minus onto this side, and then you end up with the 10 to the minus 12, that already, it's not minus 12 to the plus 12, because you would have forgotten about the minus sign here to transpose it over to the other side. That means your answers are out. You might get an error message here on your calculator, or you might get even a funny or different answer. I said this from the beginning. When you solve your mathematical problems with chemistry or physics, do not skip steps. Write them step by step so that you make sure that you don't make mistakes. when you do your calculations. And most of the time, because we are working on a small scale, the concentrations that we're working with here are expected to have the minuses here, not the plus. Once you get the plus here in your calculations, be alert. There's something wrong with your calculations. Go back and recheck yourself. So we do have the concentration of hydronium ion. You can either use the formula here to get the concentration of OH minus, or you can come directly here. This is another option. You've got the pH of 12. It's given to you there. This one is unknown, and this one is 14. Remember, 2 knowns and 1 unknown to solve for X. And there is your POH. What did I say to you previously? The question here is asking the concentration of the pH. But let's say for P's sake, they wanted the pH, and you end up with the POH of 2. You come back here so that you can get the exact pH of the base, not the acid in that solution. Once you have your POH, you can go ahead and calculate the concentration of your OH minus. So you've got too many options to work from. The tips, I presume they are learned and they are seen and observed. In your calculator, you'll never come across the 10 to the minus pH, but it's the 12. Then why not write it down step by step? 12, I'm writing again, it's minus log of H plus. Minus 12, it's log of H. I'm teaching mathematics now. This is 10, it becomes your base, and your base becomes the exponent. Then 10 to the minus 12. You see this minus 12 here is the same as what you have here. Write something that you'll be able to punch on your calculator and solve your problems. Because if you leave it like this, remember your mind is tense at some point. And then you end up seeing this and you don't know what to do with it. Then you start doing funny things to try and be wise or clever. Can't be if you originally write your things step by step and you substitute immediately into your equations, you will never come across problems like this. And then is there anything else that we need to ask or highlight before we move on to the next phase? Anybody? Kanye?
Yes, Doc.
Are we still on the same side? Any comments or questions?
Yeah, we're still on the same side. There's nothing on the chat box, ma'am.
Okay, so can I move on to the next part?
Yes, please.
This is the one that is very out of line, this question here. We've got the question, the statement up there. And learner titrates sodium hydroxide solution with a sulfuric acid, hydrochloric acid. And these are the concentrations. They gave me this. The learner uses the pipette to transfer 20 mL of sodium hydroxide solution into a conical flask. So you've got 3 conical flasks, flask 1, flask 2, and flask 2. And then you titrate. This is sodium hydroxide in here. You add the indicator. First thing that comes to your mind, what kind of an indicator are you going to add in here? They might ask you that. Because you know sodium hydroxide is a strong acid and it's in the flask. So you are going to add phenolphthalein. If your sulfuric hydrochloric acid was in your flask, you would have added it either methyl red or methyl orange, depending on what is it that is titrated with. Going further or forward, I gave you the type of an indicator. Why do you choose that? Because the sodium hydroxide is a strong base and the pH will be above 10, which will be compatible with the pH of the phenolphthalein. The color changes, you bring all of this to mind. If I add the phenolphthalein to the sodium hydroxide, my solution that was clear, it will turn pink. If I add the same indicator in my HCl, the solution will remain colorless. Remember the table that we dealt with up there. The solution is then titrated with hydrochloric acid until the endpoint is reached. The titration is repeated 3 times. Why do we repeat the titration 3 times? Is to make sure that we obtain accuracy and reasonable results. And we want to be precise. How do we know if this is correct? And how do you know if this will differ? The third one will tell you that you're on the right track. And then from here, we only use one volume. They will ask you what to do with this. Calculate the average volume. To get one volume, obviously, that is what you will do. You will take the 3 volumes and divide this by 3. You've done this even with physics, with maths. You do the average, you do the midpoint, you do the mean, and so forth. I'm going to continue beyond this. This is just something that is petty for us. Prove with a calculation that the initial concentration of sodium hydroxide was this. They gave you HCl and the information on the HCl. The concentration and the volume you got from what you calculated up there. And since HCl and sodium hydroxide, they react on a 1:1 mole ratio, this automatically gives you the number of moles of sodium hydroxide. But they want the concentration. The formulas are there at the back of your question paper. I don't need to remind you of these formulas, and that should give you your final answer here, which is the same as the one that they have requested. That is option 1. Alternatively, remember C1V1 is equals to N1 and C2V2. This is also at the back of your question paper. The trick here is to remember the mole ratios, the N's. I don't like this because most of the time we tend to forget the mole ratios, and if you do that, we are out. But this question is very nice. Say, for instance, your ratios were 1:2, and when you forgot you said 1:1, you will see your answer is not the same as the one that is up there. Automatically, you can see you're wrong and correct it. But what if this was not given and you were supposed to calculate it? So when you're using option 2, you need to be vigilant and remember the mole ratios and apply accordingly. The stoichiometry plays a big role in the acids and bases. And those of you who were here in the prelims and even with the June exams, I have posted a video on acid and base titration. It's a 45 minutes long video. It should be there for you to see. You can go back there. It highlights the importance of having 2 protons or the 2 OH minuses in the acids and bases and in the calculations of the pHs and the pOHs. So I strongly urge you to go and look into. So before we move on to the next question, can I continue or do we have questions on this? Are we fine? So far, so good? Okay, if I don't have any response, I'm going to move on. This is the naughty part. This one here. Can you see that? What is, yes. Can you see what is flashing there? Once you see the 7 marks, you're like, I was coming along very well, but now what happened? What did I do wrong? But there's nothing wrong that you did there. You're going to read your statement up there and follow it through. 10 grams sample of the rust remover is weighed off and transferred into a volumetric flask. Thereafter, the flask is filled with distilled water up to 215 ml. 10 cubic centimeter of this solution, it was diluted to make a new solution. And then it was titrated with the 24.5 cubic centimeters of sodium hydroxide solution. The equation is written down here. Most of the time with basics and basis, the examiners are nice, they will give you a balance equation. But bear in mind, they might ask you to balance the equation. And another thing, I have noticed that in their statements, they write sodium hydroxide, hydrochloric acid, sulfuric acid. Sometimes they might not be nice to even give you the formulas. They will write them up there and they say to you, write down a balanced chemical equation. I am urging you to recall from the data syllabus where you did naming and writing of compounds. That is what we used to call nomenclature. If you don't know that sodium hydroxide is NaOH and phosphoric acid is H3PO4 or sodium phosphide is that, then you're out. But I think they're nice. They won't do this to you, but just be alert and be prepared for that to happen. Question says here, the 7 marks, calculate the percentage by mass of phosphoric acid in the original undiluted rust remover. One of this, it's not difficult. I know you know what is a mass percentage, and you also know now that this is phosphoric acid. But what steps must you follow to go back? You go up here. I'm going to show you what is in the memo so that you look out at the link to answer this question. The information there that you need for your calculations, the formulas are here. I just put it there so that you recall. Back to the 7 marks. They gave you the initial number of moles and the concentration. That will give you the number of moles. From there, you decide, what do I do with this number of moles? You go back and read. They also gave you the formula, the equation. Sodium hydroxide and phosphoric acid is balanced. There's your mole ratio, the link between sodium hydroxide and the phosphoric acid. This is where you apply your stoichiometry to get the phosphoric acid. Remember, you are driving towards getting your phosphoric acid. Now that you have your phosphoric acid, which came initially from your sodium hydroxide, the link, and then your phosphoric acid. From there, sorry, my throat is just official a little bit. That will give you the number of moles according to the mole ratio. Now that you have this number of moles, then we can go back and focus on what is happening. The question asked is what is in the 250 cubic centimeters of the solution? And they said they took a portion. So this is 10 times dilution. I think the trick here in this question, it would have been the 10 here, apart from you taking the root and the blend to get to the number of moles of the phosphoric acid. This one here, and you see it here, it's going to come again in the finals. Let us not ignore it. We need to pay more attention to it. And for beyond this, you've got the number of moles that you want, and then you can continue with your calculations to get your final answer. I think from here we know what to do. It's just getting from the initial statement of what is given to you to what is being asked of you, and the other funny things that are funny or tricky. In the past or previous years, the questions were straightforward when you got here. Most of the time, they will ask you to calculate the pH of phosphoric acid. You've got 3 protons here. This is where you will show the mole ratio of the pHs previously. Right? 1 is 2, 3 for phosphoric acid and H3O plus. You've got the concentration, let's say for instance, or you've got the number of moles of phosphoric acid. That means here, the number of moles of your H plus, it will have to be 3 times the number of moles of this one here. Previously, that's what they asked. But this time around, they decided to talk about the dilution factor. which is what is happening here in this portion here. They might even ask you about the empirical formula. Anything can pop in these types of questions. But from the 7 marks, I can assure you that you will definitely get 5 out of 7. That is if you miss the 10 here. But let's say you didn't know, you forgot to use the 10. You just said 250 times that, you get that funny number, and then you continue with your answer. You still carry on because everything else does not change. The only thing that is changed is that you missed the 10 here. Prof, any more extra input before we carry on?
No, I'm happy. I think what we need to do is that they should understand the 250 over 10, like you said, is the dilution factor. We only took 10 out of the 250. We didn't titrate the whole. So we must multiply that by the number that will give us everything that's contained in the diluted one. So that's all. Anyway, you did a good job. I also understand. We can just open up and see if they need clarity. So the trick here, like you said, is the dilution. We just took an aliquot of 10 out of the 250. But the question doesn't want only from 10. It wants from the whole bucket, the 250. That's what is a trick there, which they must bear in mind.
But before we even get to this part, remember the basics. You have your initial amount, the used amount, and then the leftover or the excess, which is what we have been doing here. Previously, they gave you this to look into. They gave you the excess. You will say before you even get to the used here, before you get here, you do the mole ratio, you will get the initial and the use of the sodium hydroxide or the excess whatsoever. Then you get the use, then you use the mole ratio, then you get the number of moles of the other unknown, and then you can continue with your calculation. See, they've changed the motto here. They did not use the initial and the use and the excess. They just gave you directly the use so that you don't deal with the excess and the what. Yes?
There's a question from Sabelo. Uti, can you please repeat 250 over 20 step colleague?
250 over 10, she made a mistake.
This one
yeah,
here.
It's 250 over 10.
Okay.
Yeah, she'll explain. Doc, did you get that? She wants you to explain the dilution. Why are we multiplying by 25, for example? Why is it necessary? It's what I've just said earlier on, but maybe you may repeat
Remember,
it.
I was drawing here. I said, as you were talking, I was drawing to show you this is what Prof is saying. This is your original content. Just like when you make Oros drink, you take a portion from the original, which is concentrated, and then you add it in a glass to dilute. Do you take the whole thing and put in here? No, you take a portion, which is your 10 in this regard. You put it into a new container and then you dilute to the same volume as the other one. So that will give you, this one is 10 times diluted. Now, when you come back to the final calculation, you need to remember that initially I did not have 10 cubic centimeters, but I have the 250. So you have to come back and factor in this portion there. Is that clear enough? Sabelo, are you answered?
Let's say you have a teapot of 250 and you just take the cup. Let's say the cup it's 10. So that's the analogy. You didn't drink the whole teapot, you drank only 10. But you know that the taste of that it will be in the teapot. So you want to know how much now of what you have in the teapot has the same constituent, and it's a dilution factor. So they want the original. They don't want what you've tested. They just want the original. So you must multiply whatever you have by what we call the dilution factor to get the original. It's sort of number of moles. You can even think of it as number of moles. Thank you.
Thank you, Prof. And we find, guys, with all the added information, you're getting, tips from all over. Your questions are also the tips. Because once you answer a question, we are able to address it more and deeper. Right. Can I move on? This is all that I wanted us to look into when dealing with acids and bases. And I don't think we will have time to look at everything else, but at least we have dealt with the most hectic parts of the paper. Now, this is the chemical equilibrium. Again, it is very important to read into your statement. What is meant by chemical equilibrium? Everybody must know this. There's your 2 marks that you owe to me, and I want to see it in your final mark. Use Le Chatelier's principle to explain how an increase in temperature will change the color of the solution. They gave you this. Do you see that? Giving you this, they are saying that reactant plus reactant will give you the product plus the heat. Heat is given off. This is exothermic reaction. Before you even go any further, stop here and then you can address everything else. Use Le Chatelier's principle to explain how an increase in temperature will change the color here. If I increase this heat, what will happen to my equilibrium? Will it shift to the left or to the right? Answer that one quickly. Yes? Come on, guys. I increase the temperature here. What will happen to the equilibrium?
Again, a tip from the uncle. We normally use these words, more for less and less for more. That's Le Chatelier's principle. I will repeat, less for more and more for less. Now check there. If she adds heat, where will the heat be more? It means if it's more, it will favor the one that has less heat. And if you just memorize these words, you will never go wrong with Le Chatelier's principle. Less for more or more for less. So there we are. Try and apply what we've said there. What happens when you add heat?
I want them to snap this again.
Yes.
So if I increase the heat, there's more on this side. And there'll be less on that side. More for less.
Sabelo is answered. Sabelo is answered. Sabelo is. I think she said it will move towards the left. I can't remember, but I saw something. But now, remember, we're referring to the colors. Yes, it's correct, but
You
yeah.
must start with the left first so that you see. I mean, if you just decide the color, Sabelo says it will move to the left. What is on the left? It's yellow. Now you can come and give us the color.
Yes.
Are we clear, guys? Use Le Chatelier's principle. Explain how an increase in temperature will change the color. So initially you had an orange color. Once you increase the temperature, your equilibrium will shift to the left and favor the reverse reaction. And then you come and conclude the orange color will change to a yellow color. I think that question is also addressed here in 6.13. A concentrated solution of HCl now is added to the equilibrium. What does that mean? It means you are increasing the concentration of H+, common ion effect. What is the effect on the concentration of the dichromate ion? This one is. And hence on the color of the solution. Will it increase, remain, or change? I increase this more or less.
There you are.
Okay, but it's the same thing that we asked up here. You increase this, you have more of this, less on that. That means your equilibrium here will shift to the right. So that means you will have an orange color here. But that's not what they're asking you. They're asking you, what is the effect on the concentration of the dichromate? Will it increase, decrease, or remain the same?
And on which side is your dichromate? That is very important as well. You know, on which side of the arrow of the equilibrium.
All this
yeah.
Okay. It's cleaner now. Where's your dichromate? We have that established that the equilibrium will favor the side where the dichromate is. Where's your dichromate? The left-hand side or the right-hand side? You see in this question, they told you what is the dichromate. There it is. In other questions, they might just say dichromate, just for you to know what is the difference between the dichromate and the chromate ion, to confuse you. So the importance here is for you to recall in future. This is a chromate ion and that will be the dichromate. Then you'll be able to answer your questions. Are we ready to give answers, or should I go ahead and spoil you? At least for this one, you spoiled me. Let me spoil you with the following one. 1.2. That's what we said. We addressed this in 6.1.2. 6.1.3, if you add this, you increase the concentration of HCl, common ion effect. The system will favor the forward reaction. So you'll have more of the dichromate. That means your dichromate will increase. And this is the reason why your dichromate ions is increasing. You know what is nice about this whole thing? We used our own words to explain this before we even come to the solution that is provided in the memo. Do you see that we are speaking the same language here? In our own space, we spoke about the increase, the common ion effect, increasing the concentration, equilibrium shifting to the right or favoring the forward reaction. More of that comes, and then the color changes, we also refer to that. So do we see we've got many ways to tackle one question or one problem, and we are able to get to the same goal at the end of the day. I'm going to continue to the next phase. We've got 30 minutes left. This is the rice section. Like I said, this question paper, it was very, very, very easy, guys. Don't think you might get the same question for your finals. Everything is straightforward. You see why I'm even jumping through things. I'm just spotting and highlighting the things that I think might be problematic, or the things that we might need to prepare for the final paper. They did not ask the things that are difficult, that are trying to crucify you guys. And if we pray hard enough to get the same paper, I'm telling you the distinctions will sit in our way. I've got the equation here. Carbon monoxide and carbon dioxide and carbon, gas, solid. It's been long since they've used different phases in the KC or in the equilibrium. KC is 10 at this temperature. At that volume, or in that volume that is sealed, the temperature of 1095 contains carbon monoxide and carbon dioxide. And then an excess of solid carbon is formed according to the reaction that we're looking at. The concentration of carbon monoxide is given here, and the concentration of carbon dioxide is given. Once you're given the two concentrations, you must expect to calculate the Kc. If they give you the Kc, you must expect to either calculate the amount of the reactant or the product. And again, expect to be asked to calculate them at their initial state, the change, or at equilibrium. And those are the marks that really weighed 8 or 10 marks previously. But this time around, life is easy for us. Can I stop? I think I'm hearing someone talking in the background. Okay. Is the system at equilibrium? Support your answer with the calculation. They gave you the two concentrations. You calculate the Kc, equilibrium, and Kc are body bodies. They go hand in hand. Once you get your answer and C is the same as what you have up here, you will say yes. If the answer is different, you say no. 6.2.2, carbon dioxide gas is added to the system and the mixture reaches a new equilibrium. The concentration of carbon monoxide and carbon dioxide are now equal. The temperature remains the same. Calculate the amount in moles of carbon dioxide that was added to the system. You've got two ways to solve this 6.2.2. You can either use the rice table or you can use the long method calculations. You've got the concentrations up here. You've got the volume. You can get the number of moles of either one of them. And then you will use the mole ratio to get the number of moles of the other. And then you can continue the calculations. I prefer to use the table for my chemical equilibrium. Others prefer to use the long method. The long method I don't like because here, I'm going to show you the table now. Let's see if we come across the table. Okay, this addresses 6.2.1. If you use the concentrations to get your Kc, you see your Kc is the same as that one there. Hence, you will say the new Kc and the original are the same. Therefore, your system is the same. The question was just tricky, but what is important here? Why they asked this? I know the examiners are out of line. They are asking for the stoichiometry here. Your Kc is the product over the reactant. Your product has got coefficient of 1, which is 1b. Your carbon monoxide has got a coefficient of 2, which you needed to put b. Sometimes we tend to forget. And if you did forget this, your answers will differ. And some of you who did not get the 3 marks is because of the 2 here and nothing else. So we need to be vigilant and keep in mind that. And again, carbon, it's a solid, and the solid has a concentration of 1. Sometimes they will even give you the carbon monoxide and the carbon B without the carbon dioxide. Your Kc expression in this is that. Let's say you've got carbon and carbon, solid and the gas. Your Kc here, it's going to be 1 over concentration of carbon monoxide. Remember that. Let's say there's two of them here. Squared. Don't forget that. Here, it's going to be carbon dioxide times 1. We are just bringing everything that we know so that we don't miss out for our exam preparation. I'm going on to 6.2.2. I want to show you why I am tending to prefer the table to the long method. This is the long method I was referring to. You will start using this, you get the information on one, and then you use the mole ratios and so forth. You see how long the steps are. Unlike when you use the table, everything is here. So if you use the long method like this one, you start, let's say they say you must calculate the initial and give you the information on this one here. You need to move from here to there and there and there, and then this one will give you that one. So it's a long process. So along the way, you tend to miss the steps and make mistakes in your calculations. But if you use the table, everything is plugged onto the table. You're able to do your calculations in one and see your mistakes as they come along. Are there any comments or questions before we move on to the next part, which is almost the last bit? I think we will just rush through the rate of reactions and then the organic chemistry. I just want to highlight and emphasize some things to you before we close up. Is there anything else that we need to highlight and cover here?
Thank you very much. It's just the matter of explaining to them why the solid carbon will just be 1, because that's very important. Yeah, just emphasize on that.
According to the KC, whether it's KC for constant of a general, Ka for acid, and Kb for base, and Kw for water. Let me go back. I need a clean space here. Let me use Kw. That will be the concentration of, what am I doing here? I'm out of line. Sorry about that. H plus, aqueous, OH minus in aqueous solution. I'm just going to use that for now. H2O liquid. See that? The Kw expression of this is going to be the product over the reactant, which will be water, according to what we have here, over H plus OH minus. Sorry, not plus. You gosh. Right. But this is in a liquid form. So I'm going to have 1. I'm going to tell you why is it 1 over H plus and then OH minus. This applies to Kc, Kw, Ka, and Kb. Remember, this is for the base, acid, water, and general. Why is this 1 here? The concentration of the solids and that of the liquids, they are both equal to 1 mole per decimeter cubed, according to the equilibrium constant. Hence, when we come to such expressions here, we refer to them as 1. They are always there. The reason why we never include them in this, what a routine looks like. Let me take it off. The reason why here we don't even include it. What is 8 times 1? 1 times 1, 2 times 1. Any number multiplied by 1 will be that number. Hence, in conclusion, to here, we say Kc is equals to the concentration of carbon dioxide times the concentration of carbon over carbon monoxide squared. This is the same as you saying that's my ink is on strike now. Concentration of carbon dioxide times 1 over the concentration of carbon monoxide squared. So the one here, it's this one here, which is the concentration of this. Hence, we don't include it in the Kc expression, and you will end up with the carbon dioxide over the carbon monoxide up there. I think the pen does not want one to write fast. If you write fast, it just goes on strike. It wants you to write slow. So are we clear why whenever you come across liquid here or solid, you will have 1 instead of, and that 1, it's still included in the expression, but it's just 1. Like I said to you, A times 1 is A, 1 times 1 is 1, 2 times 1 is 2, me times 1 is me, and so forth. I hope it's outlined or laid out clearer. Unless if there's anything that we need to add further.
No, I'm happy. Let's move on.
Okay. Before we go on to the rates of reactions, I took this one from the multiple choice questions from the paper that you just wrote now. And because I didn't want to put too much multiple choice into this, I said, no, man, let me bring this one back. I've got nitrogen monoxide and oxygen giving us nitrogen dioxide. And I'm also noting that. I'm not going to read whatever that is in here. I want you guys to look into the graph here first before we start reading there. This is the first equilibrium. A change happened here. The second equilibrium was reached. A change happened again to disturb the equilibrium, and then you got the third equilibrium. So there's 1, 2, 3 equilibriums that you're looking at here. You see here, something changed. It could have been the temperature, the concentration, the catalyst or pressure. Same applies in here. Now, a change was made to the equilibrium of the gas mixture. The mixture returned to equilibrium and the second change was applied. The following graph shows the effect of the 2 changes. Something might have changed here. You see the curves are sharp. Not sharp, they are smooth. Most of the time when you see such a change, you must expect that the concentration might have happened here and the pressure. Catalyst has no effect or whatsoever in the change in the equilibrium. Here, this is smooth, smoother. That is sharp. You see the difference between this one and that one there. This is as a result of the concentration, of the temperature, sorry. And that will be your concentration, change in concentration, like here and there. Temperature might have been the influence there, and there it might have been the concentration. So that is how you clearly see them. With the catalyst, not the catalyst, I'm sorry, the pressure, or even the catalyst. Let's say this is your first equilibrium, and then you see this. You see there's no change, everything is the same. It means here a catalyst was added. And in terms of the pressure, it will depend on your equation. I've got 2 plus 1, which is 3 here. Here I've got 2. So left-hand side has got 2 moles, right-hand side has got 3 moles, and the right-hand side has got 2 moles. That means this pattern will not apply here. So it means pressure. It might not even be viewed in this, but even here, it can be one of the pressure changes. So once you see the patterns and you understand them from the graph itself, it will be easier for you to come and answer what you're looking at here. Identify the applied changes that best account for the sample of the graph. What the temperature change they told me, Here they told me about the concentration. It depends, guys. It depends. Okay, on what you're looking at. I'm not saying all the time this is the case, but if you are to compare what you have here and here, without them telling you, your first guess, it will be temperature and that will be your concentration. But in this regard, they told you, so you don't need to guess. In A, temperature changed, the concentration changed. Is that so? Prof, unless if there's something that you needed to add on here, I just wanted to highlight the importance of noting the changes in the, what you call it, the changes in the equilibrium. If it was disturbed, what could have caused the change between the concentration, the temperature, the pressure, and the catalyst?
No, that's good.
Yeah, I just wanted to highlight that one day, not necessarily to answer this question.
I understand. Thank you very much. Thank you. It's fine.
Okay. This is the rate of reaction. Independent variable, control dependent variable, and then what else is strange here? Nothing is strange. Remember, define the rate of reaction. Remember that. And again, use the collision theory and explain the trend observed in this experiment. The collision theory might include the surface area, the concentration, the temperature, and I'm not sure about the pressure. But I think the three here are the ones or the core that can be highlighted or addressed in these questions. Another thing that I think kills us here is this one. It's 1 mark most of the time. Identify or write down the question of the investigation. And what else? I think they will say identify either the independent or dependent or the control or write the question. This is 1 mark, but you will find learners spending 10 minutes trying to figure out what is the independent variable. It's 1 mark, guys. If you don't know it, skip it, move on. You will come back to it once you're done with the rest of the people. This is only in question 5. You still have 4 more questions to go through. You took 20 minutes of the entire questions just to address the 1 mark that you might not even get right. So if you're not sure from the onset, leave that question and move on to something else. But it is important for you to put a star here to say, I'll come back to this once I'm done with the rest of the paper. Remember, the importance here is for you to go and answer all the questions that you know the answers to. Put them on the paper, and then you will come back and top up with the ones that you were not sure of. Because I know the ones that you know, you won't hesitate. You put the answers down and then you move on to the next questions. I think we've got 10 minutes before we can address anything else. Are there anything that you need help with, learners, regarding the rates of reactions before we move on to the organic chemistry? I'm so sorry about the time and the delays. But I think in between our sessions, we've given you the platform to ask questions and so forth while we're busy going through the presentation, instead of us going through everything and then there to ask in the end. It was best and wise to ask while we were in between the session itself. So before we move on to the organic chemistry and looking at the tips, are you able to, or are there any questions that needs to be highlighted here? Yes, guys, while I'm still moving on with the slides and so forth. These ones I'm just rushing through because I know you know the answers to these ones, except for this one here. Maybe you might not understand, give the reason why this disappears. These are those types of questions that it's not like you don't know the answers to, but it's 1 mark. you can't think what is this mark, leave it and move on. If you know how to answer it, just put your answer down, but do not spend more than 1 minute trying to answer 5.2.3 because you are just killing yourself unnecessarily. 5.2.4 is compulsory. You must know this. I am urging you to go back and read into this so that you can give us the answer. It's the same thing, nothing changes. It can either be the concentration, the temperature, the catalyst, or the surface area. Everything, the answer will be the same. It will be along the same lines. Okay. So before we move on, are there any questions or comments?
I suggest we move on because I know your organic chemistry, you put it so well. I don't want them to miss it.
Unfortunately, I will just have to rush within the 9 minutes that is left of us for the organic chemistry. But here are the tips. Okay? I am giving the primary, secondary, propene, and so forth. The first thing that somebody asked me in this session, in the beginning of the first question, you asked me to write the chemical formula. I did that. You're going to do the same here. Under this primary alcohol, you will write the structural formula, and this one, and that one, and that one. It is easier for you to see what you are doing when you're looking at the formulas for the structures. You can't just say bottle A and bottle D. What is that? What are you answering here? Are we clear, guys? I know it's an alcohol plus a carboxylic acid to give you this. This is general knowledge. These 3 marks are, they must be here on the table for you to give us. Bromine and water, it will give you this. But while we are still on this 4.1, these are not only the reactions, the substitution, and then there's that one here, substitution of the alkanes, and it's got a mechanism. Remember that one of bromine with the UV light, and then you form the radicals. And then we also have cracking. The polymers are off your syllabus, you're lucky. So whenever you are looking in this, I guess you've got the question paper that you read now, and which is the one that I'm looking at right now. You bring along everything that falls under here when you do your revision. It's going to be easy. It will guide you. Well, Hyman, these are not only the reactions, it's not only the esters or addition or elimination. We have substitution. We've got all of you. Bring them here and then you do your revision along this section or under this section. Use the structural formula to represent the chemical equation. Sometimes they will say use the molecular formula. Structural formula. This is the structural formula. Molecular formula, C2H. Okay. We must learn to follow instructions. Once they say formula or the structural formula, when you use this one, already your 6 marks is gone, unfortunately. And you know why is this 6 marks? Because you needed to have written this. And I told you from the previous. Oh, you just memorize it, does not go there. Oops, sorry about this. I forgot to erase the board. So we will have this as our structural formula. And you have written this already in the bottles up there. By the time you come here, you don't struggle. You got them because your mind was clear while you are looking into the statement. The questions, when you come to, it's not easy for you to try and address the question and also analyze what was in the statement at the same time. So you need to break things in bits and pieces. This is something that you practice now before you write exams. So that by the time you write exams, your brain knows what is it that is expected of you. Concentrated sulfuric acid is added. Sorry about it. I forgot to address the 6 marks. What is the 6 marks for? It comes from the formulas that you wrote in the products. This is an ester. The correct ester is written plus the water. Don't forget to write the water there. And another thing with the esters, I've seen this question asked in the previous exam papers. They ask you the OH, obviously, and the H. They come off to form this water here. H2 and the O. Somebody asks, where does this H2O come from? Does the OH come from here or does it come from there? You don't need to crack your head unnecessarily. The OH comes from the alcohol and the H comes from the carboxylic acid. Why does the H come from the carboxylic acid? Your H is your H plus. And what does an acid do? It donates a proton, which is this H here. No headaches or whatsoever, no negotiations. That's how it goes. You start with your acid, it gives an H. The OH will automatically come from the other substance, which will be your alcohol. When it's such questions, I mean, they're straightforward. That's a catalyst. I brought the bottles here again to address this one. You give the name of the functional group of bottle P. You need to have written this so that you can see the names of those, or whatever that is being asked of you. Remember here, you've got the functional groups, we've got the homologous series, we've got the general formula. You also have to define the isomer. They can ask you to write the positional isomer of this, or the functional isomer, or the branch, or the chain isomer of any of the organic molecules. So I'm just bringing you all the organic chemistry here so that you are not missing out something when you do your revision. Guys, ask questions and as we move along. There's your bottle C. You've already wrote your formulas. Name the reaction condition here. You must have written your equation so that you can see what is it that is expected of you. Markovnikov rule, once you see major product, Markovnikov rule and Zaitsev rule will apply here. Name the type of the addition reaction that occurs. They said addition reaction. You don't come back here and write addition. You need to say addition of water, or you can say hydration, or you can say addition of Br2, or the addition of HCl or HBr, because they told you here. If they said name the type of the reaction that occurred, we can get away with mad and just say addition. We still get a mark. But they gave you an answer, they don't expect to see that in here. Two products are formed during this reaction. The products can be separated through distillation. Which property of the compounds allows this separation? This is the 1 mark. Again, this question is funny. By using the different window, who could have thought of this? I mean, in your state of mind exam, you can't be thinking of these things that are far away from your scope. It's 1 mark again. What do? You leave it alone and you move on. Okay, guys, we've got 1 minute left, and I'm opening this for comments or questions, and then we will wrap up and go and prepare ourselves for the final exam. Prof, over to you.
No, that's what I'm here. My laptop
Professor?
sometimes, yeah. Guys, we would like to thank you very much for choosing your future over your instant pleasure. It's a good thing that you guys are now serious about your work, and this will help you not to fight for spaces at the universities or any tertiary institution, but the universities will fight for you. Make sure you are thoroughly prepared. Make sure you are thoroughly prepared. Do not panic. Do not panic. Like ma'am said, you had all this time to prepare. So you cannot, at the last hurdle, be deflated. The examiner does not know as much as you know. You've been working, we've helped you, your educators have been helping you. Do not panic. Do your work on time. Learn to study and have a good timetable and relax when it's necessary. When you feel tired, not during the exam, of course, but when you are still studying and you feel you are very, very tired, just learn to relax and resume. You've got all the resources you need in order for you to make it in life and in this exam. We are waiting for you on the other side of matric. And I must confess, the other side of matric is really, really very nice if you've prepared. So come join us on the other side. Be prepared and ready to go on and be victors. We thank you and we applaud you for all the efforts that you've done. This is not the end. Go and do it again on your own. You may even form study groups and help each other. There is no competition here. We just want to help each other. In the titration you saw, you did the average. So we want the average to be a pass rate, more than a pass rate in your region. Thank you very much. Enjoy the rest of the weekend while studying. Thank you. Thank you, Dr. Kunwana. You made a marvelous pie of education today. And thank you, everybody, Kanye, and then Morph was there as well, and all the participants. We know some of you are not gifted in talking, you are gifted in listening. So we thank you all. You made this a memorable day. Thank you and goodbye.
Before everybody leaves, thank you very much for making the day a success. And remember, next week, same time, on a Saturday, you are going to have a lesson on paper 1 preparation for your final exams. Be there. We will all meet there to talk about the arrows, the momentum, the what you call it now, electricity. There's quite a lot. And your paper 1 is very interesting. And otherwise, remember the recording for this session will be on YouTube. You will go and make a follow-up from there. Prof, you were saying something?
No, I was just adding on work, power, and energy, as those are the specialties of Dr. Moore.
Yes, that one also. And guys, we also know about power and energy. We just don't like to talk about it because
it's Yes, Papa.
Yeah. I just want to remind them that next week there will be a session on the 4th, same time on the same platform for physics.
They'll be waiting for you.
Yeah, I'll be there with my next team ready, so that they get what is needed for them to be prepared. Thank you very much, guys. A marvelous job that they've done. And take care.
Thank you.
Bye-bye.
Bye, everybody.
Thank you.